Okay, welcome back. This is the second video, or the second part of the worksheet number 5, and we're doing question number 14 now. So, what does question 14 says? Question 14 actually I'm doing 15 now. I skipped 14 because that's straightforward. So I'm doing 15. Okay, question 15. It says the following. It says that you have this circuit, and you wanted to find the magnitude and the direction of the current first of all, and then the terminal voltage there, the terminal voltage at VAB, and then the potential difference between there and the potential difference between these different points. So the key is to find the current. How do I find the current? I can find the current using this rule that I started with at the very beginning. Now, if I start at point A, and then I go around in the closed loop, then remember they have only one loop, so I can only do this once. Yeah. So if this is my current, 5 minus 5i minus 14i, and then remember, if I'm going this way, it's positive. If I'm going this way, it's negative. So this is minus 8, right? And again, I'm going against or with the current, so that means 9i, and then plus 16 minus 1.6i is equal to 0. And then from here I only have I, so I can collect the terms and find I. Once I find I, so I found the current. Once I found the current, then I go back in here and I say, okay, the voltage between these two guys will be 16. So this is the voltage AB. It will be 16 minus I times 1.6. That will give me the voltage across these 2 points. Right? If I wanted the voltage across these 2 points, then it's simply IR. So VCB or BC, it's the same thing. It's IR. Okay, V is equal to IR. I have I, which I calculate from here, and R is equal to that. And then plot the potential energy for the circuit. You have to plot that. So what you have to do, you have to have your that. And if I start at this point here, I'm going to go around, so I have to, this is 16. So I gain 16, and then I'm going to stay a little bit, and then I'm going to drop. I don't know what I is. I need really to calculate I. So you need to drop a little bit, and then you're going to stay drop again, 5 here, you drop again here, and then you gain some voltage, because this is a voltage gain. Right, this is the voltage gain, and then you drop back to 0. Remember, you have to go, if you start from 0, you have to go back to 0. Okay, and that's actually a very good question, and you should expect something like this in the final. This is a very good question for the final. Okay. Okay, so that's question number 15. The second question, question number. What am I doing? Which question am I doing? I'm actually doing question number from the book. Not from the book, but from the notes. We did this in class, and we didn't finish it, and I thought it's a very important question to do. Okay, this is question 26.16, and what is it asking you to do is basically asking you to find the current or the voltage, this E here, and the current here, the current here, and the current here. Okay, and he told you this is what we got confused about in class. This is what he told me the current in this resistor is. Okay, now since this is how I solve this very quickly. Since I know R and I know I, so I can get V. V is equal to I times R. So I got V here, which is 30. V is equal to IR, so that's 36V. Now the 36V is the same because these two guys are connected in parallel. So again, V here is equal to 36V. Now from here, I can find this I. I here is simply V is equal to IR, so it's V divided by R. This will lead to another. So I got I in this, and it has to be this way. Okay. So I got this I, and I have this I, and I know that the sum of these two will give me the I here. So I think what I have this is the voltage. Sorry, the current here is 4.5, I believe, if I'm not mistaken. So if the current here is 4.5 and you have 6, so that means the total current is equal to 10.5 when this is the current here. So the current here I is equal to 10, and then I can find the voltage here also. Now, once I find the voltage here, right, and the voltage here is 36, so that means these two voltages are the same as this guy, the same as this guy. So if the voltage here V, let's call it V25, V at 25 is equal to I times R. I is 10.5 and R is 25, so I get this voltage here, and then plus the voltage here, which is 36. Remember, these guys are 36. So this plus that will be the same as this guy, will be the same as this guy, and problem solved. So because once you have that, this is the voltage. What I don't know what is it multiplied by 25. So you have to work these things out. Okay, but the idea is clear. So I got, again, I repeat this. I got from here I got V, and it's the same V. So from here I get I, and the sum of these two i's is this I, because this is a junction. And this is a junction, that means I here and I here is equal to I here, right? So these two is equal to this guy, and then from here I get V for this 25 ohm resistor, and V plus 36 gives me the same V as this guy and the same V as this guy. Okay, so in here I get I, and in here I get the voltage, or the value for the voltage for the battery, or the power source of the battery. Okay, that's problem number 26.16, which we have in class, and I think, as I said, this is a very important problem that you should be able to solve. Okay, let's get back to our problems in the worksheet. Okay, so this is the second problem, which is what problem is this? Oh, this is I think just finishing the previous problem. So now we're moving into, I think the other problems are straightforward. So we're moving into problem number 6.20. Okay. In fact, we should be careful here with there's a mistake in the book. There's a mistake in the book. There's a mix-up between 6.20 and 6.23. The diagrams, or the circuits for which is 6.23, it's really 6.20, and the diagram that is given in 6.20, it's really 6.23. So this is the proper one for 6.20, and problem 6.20 says, so this is 6.20 here. Let me just show you in the book here. There. So this is 6.20. It's proper. The right diagram for it is this guy here. Okay, so that's the right diagram for it. At least unless you have a different version of from my book. So it says that you have this shown circuit, and he told you that the power dissipated in R1, the power dissipated is equal to 20 watts. So what does that mean? That means since this is equal, the current he gave me here is 2, so that means I can get R1 immediately. R1 is simply the power dissipated here is 20 watts, and the current is equal to 2, and I know the power is equal to I square R, so I immediately get R from here. Since I have R and I have I can get V, which is equal to 10 volts, so that means the voltage across here is 10 volts, which means what? Which means that the voltage across here is also 10 volts. 10 volts across these 2 points, and the voltage across these is is also 10 volts. But the current here is 3.5. It's going to split into 2. It's going to split into I1, and it's going to split into I2. So that means I have an equation where it's 3.5 current is equal to I1 plus I2. But I can get I2. Well, how do I get I2? V is equal to I R, right? And V is equal to 10, R is equal to 10, so that means the current here is equal to 1 amp. Okay, and then this guy here is going to be is going to split into I3 and 2. Okay, so that, but this guy here is 10 volts, so that means I also can get remember, this is if this is 3.5, if this is 1, that means this guy I1 is simply 3.5 minus 1, which is 2.5. So this guy is 2.5. What does that mean? That means I have this is going in, this is coming out, this is coming out. This is I3, and this is 2, right? 2 amp. Right? That means I can get I3 simply because 2.5 2.5 is equal to 2 plus I3. So that means I3 is 2.5 minus 2 is equal to 0.5 amp. And if I get that and I have the voltage, I can get R2. Problem solved. Okay? And that's the solution to the problem. So basically I have to work from there and then go this way and then go back. And remember, if this is 10, 10, 10, this must be also equal to 10 volts. Okay, that's the solution to this question. As I said, you just have to go slowly and take it, just make sure you can solve each one of these systematically, step by step. Okay? All right, so if we go back now to the second question, which is 6.23, 6.23, and 6.23 is really this question, the 6.23, which is this here, but the right diagram for it is this circuit right here. It's this circuit here, which is 6.20. Okay, so what does the question say? The question says that in the circuit, a 20 ohm resistor, this 20 ohm resistor here, which is, remember, this is connected to the combination, this combination here. There's a lot of resistors here. Okay, and then they have the circuit going in. There's a 5 ohm resistor there, and there is a voltage or a battery that is 30 volts there. Now, what does he want? He wants to if the water is initially at 20, how long will it take the water or the temperature of the water to rise to 58? Okay. Now, what does this mean? He wants the power, which is defined as the work divided by the time, and the work is simply equal to the heat given to the water, which, if you remember from physics 1, the heat added, this is the amount, this is work, right, or energy, work or delta energy, okay? And this is Q, it's the amount of heat added, because the work in this case is equal to the amount of heat added. And heat is simply defined as mc delta T. M is given, he gave us the mass of the water. C of water is, I pulled it out from so that's a constant. And delta T is simply the difference between the temperature, which is 58, what's the temperature here? 58 minus 10. So delta T here is 58 minus 10. And time is the one he wants. That's the thing he wants. So what does that mean? That means I have to calculate P, the power. How do I calculate the power? If I know the resistor, that means I need I. I need I because power is equal to I square R. So if I have R, in order to calculate the power, I need I. Well, now you know, I think the problem is solved, because all I have to do is just look at this circuit and then solve for I. That means what? That means I have to combine all of these guys, these two in series, these two in series, these two in series, and then they combine them as all in parallel, and then I have a circuit which will be something like this. Let me just check its. Okay, so where is that? So it's something like this, and then I have a resistor here, and all of these guys combine there, and I have the 20 ohm resistor, and then I apply the sum of the voltage is equal to 0. I can go this way, so that I go with because this is negative and this is positive, and it's equal to 30 volts. Okay, 30 volts, and then I can go around, and then I can calculate from here. I can calculate I, and I, it will be this I over here, and then from there I calculate the power, and I go back to my equation and I solve for T. Okay, so again, just to make the videos shorter, let me stop here, and then I'll continue with the remaining problems in a few minutes. Okay, thank you.